So for our integral calculus topic, we have here our 5 problems. Now let's begin to solve for number 1. So for number 1, we have here the integral of 1 over 1 minus sine squared x plus sine x dx. So in order to solve this, we will apply Pythagorean identity for our 1 over 1 minus sine squared. Now we have the integral of 1 over cosine squared x plus sine x dx. So our next step is to convert our 1 over cosine squared x to its reciprocal identity and split the integral into 2. Now we have integral of secant squared x dx and integral of sine x dx. Now we will apply the integral of trigonometric functions, which is the secant squared will become tangent x and the dx will become plus c or plus constant minus the integral of sine, which is cosine x plus c. Then we will simplify. Now we have tangent x minus cosine x plus c as our final answer. So for our number 2, we have here the integral of 4 cosine x all over sine squared x dx. So in order to solve this, we will differentiate both sides and we will need to get our u. So we have here our u, which is sine x, and then if we differentiate both sides, we can cancel the cosine x. Now we have the integral of 4 over sine squared x in terms of du. Now we will reduce the expression into the lowest term, so we will substitute our u. Now we have integral of 4 over u squared du. Now we will pull our coefficient in front before the integral. Now we have 4 integral of 1 over u squared. Now we will integrate our 1 over u squared. So now we have 4 times 1 over negative u. We can write this as 4 times negative 1 over u. Now we will have negative 4 times 1 over u. Now we can substitute back the value of our u, which is sine x. Now we have negative 4 times 1 over sine x is equal to negative 4 over sine x plus c. And that is our final answer. For the problem number 3, we have integral of 4w minus 1 all over the square root of 4w squared minus 2w dw. So first, we need to get our u, which is 4w squared minus 2w. And we will find the value of our du. So we need to derive our u, which is 8w minus 2. Now, since our du can't match our numerator, we need to divide it by 2. Now we have 4w minus 1 as our du. Now, we need to substitute everything in terms of u and du. So we have integral of 1 over 2 all over square root of u du. So we can pull the 1 over 2 in front before the integral sign. Now we have 1 over 2 integral of 1 over u, 1 over 2. Then we need to bring u to the top, so its power will become negative. Now we're ready to integrate, so negative 1 half plus 1 will become positive 1 half. Now we have 1 over 2 times u 1 half over 1 half plus c. Since we will divide by 1 half, that is the same as multiplying by 2. Now we have 1 over 2 times 2 u 1 half plus c. So 1 over 2 times 2 will become 1, and then we will substitute the value of u, which is 4w squared minus 2w 1 half plus c. Now if we multiply this, we will have 4w squared minus 2w 1 half plus c, and we can write it now as a radical form, which is the square root of 4w squared minus 2w plus c as our final answer. And for number 4, we have integral of x to the 4th power minus 2x cubed plus 3x squared minus 1 dx from negative 1 to 2. Now we will just integrate this linear expression. So after we integrate, now we have x to the 5th power over 5 minus 2x to the 4th power over 4 plus 3x cubed over 3 minus 1x from negative 1 to 2. Now, if we divide, we can cancel our 3, and 2 divided by 4 will become 2. Now we have x to the 5th power over 5 minus x to the 4th power over 2 plus x cubed minus 1x from negative 1 to 2. Now what are we going to do here is we can substitute the value of negative 1 and 2 into 2 terms. Now we have 2 to the 5th power over 5 minus 2 to the 4th power over 2 plus 2 cubed minus 1 times 2 minus negative 1 to the 5th power over 5 minus negative 1 to the 4th power over 2 plus negative 1 cubed minus 1 times negative 1. Then, if we can calculate it in our calculator, we will have our final answer of 51 over 10. Now, for our 5th problem, we have the integral of 5th root of x to the 9th power dx. And we can write it as integral of x 9 over 5 dx. Now, if we integrate this, we can have x to the 14th power over 5 plus c. Then, what are we going to do with the power is we will multiply it by the reciprocal. Now we have x to the 14th power over 5 times 5 over 14 plus c. Then we have 5 over 14 fifth square root of x to the 14th power plus c as our final answer.